we are going to talk about something surprising and new. So I heard that only a few of you have already know about MySQL 5.4. Who has tried it? Wow. Okay. Good. This is something special. Okay, there are two reasons why this release is special. For the ones who didn't know, MySQL 5.4 was announced at the users conference in April. So on the 21st of April, surprise announcement, we have a new release. But the reason why this release is very special is this. We had MySQL programmers and some performance engineers working together on this release very tightly, and they created this with an extremely good example of teamwork. So we have the MySQL engineers who are the experts of the code, and we have the Sun engineers who didn't know the code, but they are experts at performance. So it's a team of people who took Solaris and increased performance 50%. The same team of people increased performance of MySQL 5.1 60%. So how to improve performance? This is the second reason. If you have been in the MySQL only database area for a long time, you know that there are several methods of increasing performance. Schema optimization, for instance, can be extremely efficient. However, it's quite difficult to do. When I was consulting, this was my area of maximum success. When I found a problem with schema optimization, I always managed to have an incredible boost of performance, but it's not easy to do. Then you can tune the server. You then don't get very much with that. You can tune the server, you can increase 20, 30%, not more. And it's difficult. So it's hard work, and not always you get what you want. Then you can tune queries. Also tuning queries, you can have spectacular results, but only if the initial queries were really poor. And tuning queries is hard work. You can upgrade hardware. Upgrade hardware, you can get good results, and it's very easy. You just throw away the old machine and put a new one. Anybody can do that.
Or get a new Amazon image.
Yes. Or you can use replication to scale mostly. You can get good results, but replication is hard to deal with, especially if you have one application that's working with one server only and is not replication aware. You can use partitioning. Partition is incredibly efficient. It doesn't work in every case, but you can get spectacular results. However, partitions are not easy to use. And finally, you can use a server upgrade, MySQL 5.4. You can have spectacular results, and all you need to do is upgrade. So for the first time in the MySQL history, you have something that is extremely efficient and doesn't require you to change everything. You have just to replace your server with something different. Are you curious now? No, yeah. So MySQL 5.4 is very simple. It's 5.1 plus a few performance patches. There are no new features. There is nothing spectacular except performance. So it's like MySQL 5.0, MySQL 5.1, it's just 30 to 60% faster. Yes?
Is it still the same NoDB engine, or is it the new one from Innovate?
It's the same with patches.
Does that mean that there's more visibility into the tables that give you information on how it's performing?
Something, yes.
Okay.
There are some things like that.
Now, is this only on Sun, Solaris, or for the performance boost, or is it covering all the operating systems?
Basically, it has been tested on Linux, Solaris, and FreeBSD. I have no idea if it works on Windows, and it's very low in my priority list.
On those three operating systems, is the performance improvement comparable or significantly different from hardware platforms?
Performance was extremely good on Linux, almost the same on Solaris. It's a little bit slower, and I can tell you that even though it was not tested by the makers on Mac OS X, there is a spectacular performance boost on Mac as well. So I assume that it's almost everywhere. But it changes because there were improvements that are operating system specific, like dtrace probes that are only for Solaris at the moment.
Question?
Yes.
What release was used for forking this 5.4?
Using 5.1.33. And you can see that because there was a bug, and the code that was released still has 5.1.33, and they forgot to put the 5.4.0 in the code that was released to Launchpad. So now we have two sides of the presentation. The first part of the presentation is the one that was given at the users conference by the creators. So I will go through this just to show you what the theory is. And after that I will show you what I have done independently from what the developers did. And the results that I show you are the results that I can prove and repeat with you. And since we have an internet connection, I can try to get to my servers and show you directly how it goes. So you will see the slides in my blog this evening or tomorrow morning, and you will can see the details of the implementation. I confess that some of the details I cannot explain to you, but if you have questions, I will gladly ask the developers and put in my blog the answers. So this was the title of the presentation, the users conference. Alan Parker is an engineer that is specialized in performance, and Michael Ronston is principal engineer in MySQL, is the creator of MySQL cluster and the creator of MySQL partitioning, and also he has participated into the architecture of MySQL 5.1. Okay. The agenda is simple: why, what, and some examples. This was the situation when they started. In February 2008, MySQL had a performance, a scalability problem. So you know that now a commodity hardware is 16 core. There are no 2 cores, 1 core around it. So on this particular powerful servers, MySQL doesn't scale very well. So this situation was a problem, very what can I say, painful problem, because everybody was complaining that using the new commodity hardware they didn't have the same kind of performance that they used to have before. So they started a group that tried to improve the performance using a specific goal. They just wanted to take MySQL 5.1 and make it perform much better using specifically InnoDB. Now, if you have ever done this kind of work with performance, you know that it's very tedious work. You have to run a batch of tests, find one point where the server is very slow, and fix that point. After that, you run the tests again, and you find there is another point where you have a problem. Then you fix the other point, and you start from scratch. So they have to repeat this process dozens of times, and at the end they had some results. So when they decide to do this, they decide to target specifically the operating systems that are mostly used with MySQL. So Linux is the prince, is the operating system that everybody uses, and Solaris is, of course, the main operating system in Sun. And Solaris is also used almost everywhere in big corporations. So this is why you can find the improvements mostly on Linux and Solaris. The initial plan was to find improvements for both InnoDB and Falcon. So most of the improvements are only for InnoDB, and the improvements from Falcon are outside this release. So MySQL 5.4 doesn't know anything about Falcon, and even though Falcon has improvements, most of these improvements were not the direct result of this project. So, how does performance work? In addition to finding the weak points and fixing them, we used some contributions from the community, mostly from Google. The improvements are so big that really I want to show you as soon as possible what is there. But let's go to the slide to see the list of what they have done. There are some performance that were already made in MySQL 6.0 that were backported to 5.4. There was the Google SMP patch. This is probably the most important patch that Google made. Initially it was made for MySQL 4.0, then it was ported for MySQL 5.0. And those people worked very tightly with Mark Callaghan of Google to adapt this patch for MySQL 5.1 code base, and then eventually in MySQL 5.4. They did most of the changes on the InnoDB. The InnoDB is standalone. It's the embedded server inside the MySQL core. It's not a plugin, but the changes are not invasive, so we have a plan now to release all the changes that we have made for MySQL 5.4 in a plugin. It's going to be very transparent. In addition to using the Google patches, we asked Google to test the final results. So MySQL 5.4, even though was kept secret for a while, it has been tested by people like by companies like Google, and you know that Google are very demanding. And we have something like 20 customers who tested it before the users conference. So the main part is the Google SMP patch. In simple words, is improvement in the management of the logs. And there is an improvement in the management of the memory. And altogether, this patch is responsible for 30% of the improvement. There are tests like the DBT2 that are performing much faster after this patch. I'm not very fond of DBT2 because it's a lab test. It's something that yes, gives you an idea of what you can do. I prefer to do something much more repeatable by normal users. So I will show you something different. The SMP patch was not enough to get all the results that we wanted, so the team focused on any part of the improvement that was available. They looked at the code inside out, and they tried to introduce not only InnoDB specific changes, but also changes to the code in general. The second patch after SMP was the thread concurrency algorithm. Basically, we have a problem when we have so many threads. The old algorithm didn't scale beyond 16 cores, actually beyond 8 cores. So they did something very daring in this case. This was probably the most invasive patch that they did. They completed the algorithm for the thread concurrency. I have no idea how effective this is. I can tell you that the results are spectacular. So basically this works. They changed the way that they deal with the threads, and you can see that on your servers if you try. You can see that in the slide that I will put online. Let's see the important thing that we have more. We have dtrace probes in MySQL Server. Who knows what is dtrace? You work for Sun, you should search. Okay, she knows because she wrote a book about that, I'm sure.
No, there's no dtrace in the book. I didn't want to have to explain it.
Basically, dtrace is part of the Solaris operating system, and it's also available in other operating systems like Microsystems, FreeBSD. And it's a technology that allows you to see the internals of one application without being intrusive.
So tracing the processes.
Yes.
Because they used to call it S-trace on some Solaris.
S-trace is Linux.
S-trace Linux.
Trust.
Trust. Okay. So D-trace is one that, yeah.
Well, Trust is still out there. Trust has been modified to use D-trace engine.
Oh, okay.
I think dtrace is the API, right? And trust is just the command line tool?
But D-trace is the mechanism of
Yeah.
the whole thing, and Trust is one mechanism which has been modified to use D-trace. It's just a
The command line, you can script it, or, essentially script the session so that you capture everything in the file and you just let it rip, because otherwise you're just going to get a ton of output.
Right.
Okay.
So the trace is a technology that allows you to see what is inside. It's we can call it an engine for profiling. Using the trace, even without scripting, you can find a lot. You can get a lot of information about your engine. And so the trace probes were introduced in the code. So what is a probe? If you use the trace without probes, you can just tell the trace to give you information about a specific call that the application uses when it's running. If you have probes, then you can make a more specific assumption on what is going on. So instead of saying check what happens when this particular system call is called, instead of saying so, you say, okay, use this specific probe to give me the information on what is going on there. The probe can expose more information than the call to the operating system can give you. Basically, if you add the probes to an application, you make it completely transparent to the developer.
Do the probes have to be compiled in at build, or are they something that you have to do a my.cnf parameter and then use that functionality once it's in?
You have to compile it in. If you don't, you can still use the probe, but you can only catch when the application is using a specific system call. So you can see only the exterior. If you have a probe, then you can expose also internal variables.
I'd actually clarify more on that. So there are two sets of probes you get. You get the kernel probes and the system probes. Every system call has kernel probes defined at the boundaries of the function, and that goes also for the user length probes. Apart from that, the kernel probes has additional probes which will be based on tasks or specific things you want to do. To do similar kind of functionality in user length. Say, for example, you want to do a transaction count. Now, transaction is the thing that the application knows, not the function. So in those scenarios, if you want those things to be tracked, you would need to add your own probes and compile them as part of your application. But by default, the dtrace mechanism will give you function boundary tracing, which is like, when you go from one function to another, it can capture those events.
And would you have to invoke it from the operating system, or would you be able to say, step through it like the debugger that you would say, like internally explain plan statements? Would you do the equivalent of invoking that probe within?
Right. So what we have is an op-like descript that you can define your logic of how you want to stack through or trace through your function calls.
Okay.
Typically, if you turn on probes on everything, it would slow down your system like GDB does.
Yeah.
But with dtrace, what gives you the advantage is you can actually turn on only selected probes, and you can define your own logic to see how you want to do your debugging.
Thank you.
Mostly compared to debugging is when you debug, when you compile your application with debugging information, you are slowing it down. If you compile it with dtrace probes, and if you are not using them, so you don't affect performance at all. Only when you are enabling them, then you you are slowing down to get the profile information.
Okay, so only when you're invoking them.
Yes. The dtrace was already in the pipeline for MySQL 6.0, but MySQL 6.0 is still in alpha and very, very far away. So we backported that to MySQL 5.4, and this was actively used to find the bottlenecks. You can see here a long list of the probes that were inserted. Yes?
Just wanted to clarify something. The detracing is not available in Linux, is that correct?
Is not available on Linux.
Is there more observability in Linux, or is it just specific to detracing?
As far as I know, they use the trace for on Solaris to find the bottlenecks, and then they intervened on Linux as well using a normal profiler. So with dtrace is much easier to find a bottleneck than with anything else.
Sorry, I take this as a tangent, but on the MySQL webpage 5.4, it talks about how there's more information in showing ODB status. Is that through detracing, or is that something completely else?
No, this is part of the Google patches. The Google patches, in addition to improving performance, give you more information about what is going on inside InnoDB. So this is...
That's only accessible through dtrace, is that correct?
This is accessible through dtrace if you have it enabled.
But if you're on Linux...
If you are on Linux, you get only through show InnoDB status. But also that is transparent. I mean, there is no new features in 5.4. There are no new commands, no new syntax. It's the old syntax that works better. Now, one thing that was used added here, there is a build script to make it easier for new developers to build MySQL. This build script was created for MySQL cluster. In my tests on Mac, it doesn't work well. If I use my traditional build script, that is basically the same instruction that I use for a Pentium computer, I create a 5.4 that is extremely fast. If I use the built-in build script, it doesn't give me the same performance. So I know that this is, it works extremely well on Linux. It doesn't work well on Mac, and I'm not sure that it works well on FreeBSD. So this new build script you can rely on if you are using Linux or Solaris only at the moment. If you don't benchmark before accepting. Okay, the information that you see here are the tests made by the Sun and MySQL engineers. I know very little about how were they made. I can just show them to you, and then I will show what I did that I can explain to you better. Does anybody know what is the sysbench test? Okay, sysbench is one test application that is it works for mostly everything, but it has been created by a MySQL developer, so it has some tests that work very well with MySQL.
It's on page 552.
Okay.
I'm working on it. Smarty pants.
I didn't write that yet.
Okay.
One thing that I like about sysbench is that you just write a simple script with instructions and then use that to compare results. looks like the kind of operations that you have in a normal environment. So you can fake many connections, you can fake many a mix of read and write instructions. It's a very simple test compared to DBT2, and it's repeatable. So I show you what I did, and I hope that you can do the same and compare the results and see that it was not the dreams of some developers, but it's something that you can use on your own. Mostly, yes.
Which thread are they talking about? Which threads are they talking about in this? Is this the new InnoDB IO threads? Is that what they're talking about?
I have no idea.
No, the number of active threads, isn't that just regular connection?
It's the sysbench.
Yeah, the systems user.
Yeah.
Now the way sysbench works is like this. You have to set the parameters. You tell sysbench how many threads it has to run, how many connections should create, how many rows in the table, and what kind of instructions. And then, once you set this environment, you say, run this test for 1 minute, 10 minutes, 1 hour, and you get the results. After that, you compare with the same run in a different machine, in a different set, or whatever.
Is it automatically flushing its cache at a point so that you don't have it using pre-compiled queries?
There is no automatic cache, but I did that when I ran my test. So when I run my tests, I will show you, I test everything from MySQL 5.0.45 until MySQL 5.4. Something like 20 different versions. And after each run, I cleared I shut down the server and I cleared the cache, made sure that there was no cache, anything in memory at all. So I created a 32 gigabyte file and I removed it, so I was sure that the operating system was clean.
How many cores withdraw this system?
Now in this one, they were using 64 core.
So it's one thread per core?
No, that would be 8 cores with 8 threads, 8 virtual threads each. So that would be 64. The way the vCPUs is basically known as the CPU threads. So the way the CERN CMT systems are designed is like most of them would have 1 core.
So it's on Solaris CMT.
It's on Solaris CMT. So it's
So
one
the
core,
64 ways is virtual.
Yes.
Okay. As I said, these were the tests performed by the developers, so I know very little about that.
This one looks like it was Red Hat.
They are all nice graphs.
Thanks.
And mostly they say that
So on this particular one, this is actually running on an Intel Xeon 55 running Solaris. So this is again is a different CPU.
Is it running with solid state or just regular? Just
I'm not sure what they use for this particular one, though. So they could be using very much storage for the actual type of it.
Sunfire.
But the Sunfire is just the name of the server.
Right.
It doesn't tell you about the disk. I think they could have been using Intel 1 with solid state, so I cannot know that.
okay, this is another cute graph that shows only that MySQL 5.4 is a lot faster, but I cannot tell you very much about that.
Question?
Yes.
If you just have a single CPU,
Mhm.
will we see this type of speed improvement on a single CPU? or
Yes, yes. I tested it in addition to my other computer. I don't know if you can see. I have here one stick that says my other computer is a data center. So in addition to the data center that I have in Norway, I have to visit Norway sometimes to see if this data center exists. I have some laptops with, this one has 2 cores, I have one laptop with 1 core, and I have several virtual machines with 1 core. So I have seen everywhere almost the same performance gain. And I can show you the example with my laptop and the data center. In addition to what they have done so far, they have ambitious plans to use more Google patches, to improve scalability with replication, and most of the things that they want to do is just plug and play thing. So the only thing that you will have to do is remove your old server, plug the new one, and you will get the performance. So this is the work of the performance team, that they want to make your life easier without sweating too much. I'm going to skip the details of this because I cannot tell you more. Now this was the conclusion of the developers. They say MySQL 5.4 boosts performance and scalability, and they give you some examples that are hard to replicate in your normal life. Instead, what I did, I tried to put myself in the shoes of a normal user, and I did something that was designed to be replicated by you. So if you want to have a look, this is what you can see from practical experience. Now, practical experience was done first in my laptop. This is a MacBook with 2 cores, nothing special. It's not, I mean, compared to the servers 10 years ago, this is fantastic, but compared to the servers nowadays, it's just a small laptop. What I did was using Sysbench on my Monster. The Monster has 1 terabyte storage, 32 gigabyte of RAM, and 8 cores. And it's running Linux, Red Hat, what is called the Enterprise Edition 5. So Sysbench, what is it? It's a test where you give instructions to create one specific environment and then run the test. What you see in the screen is the preparation for the OLTP test. OLTP is a test that is designed specifically for MySQL. The size of the table is 1 million rows. The name of the database used for the test is test. Then we have the user and password, the host for connection, 1 port, and the number of threads. Any problems so far? So this is instead the instruction to run the test. Once you prepare the test with the 1 million rows, this is what you say to run the test. What is important is here, OLTP read only on. It means that all the tests will only use select nothing that modifies the table. Max request 0 means that it will do as many requests as are necessary for reaching maximum time. Maximum time is 60 seconds. The number of threads is 8 again. To run the read-write test, I can change this parameter. So this is the result I got in 5.0 using the read-only setup. In this particular set of tests, I was measuring the effect on logs on performance. So in the first column, you see what is the performance without any logs. And in the second one, you see the performance with logs and the percentage of the loss.
Binary logs?
No, this is the general log. For the binary log, there is another test. You see that we have something like 29–30% loss when you use the general logs. And the important thing is that with 5.079, which was the most recent one when I ran the tests, we have something like 4,000 transactions per minute. 5.1 read-only. In 5.1 we have not only the general log as a file, we have also general logs as tables. And the loss with tables is consistently higher. Anyway, the important thing is that the final result for 5.1 is lower than what we have in 5.0. There were performance bugs in 5.1, and if you see the numbers here, they are growing over time, so they were improving, but they were not as good as 5.0. However, the loss in using the general logs is less than what we have in 5.0. So we can say that 5.1 is less performing than 5.0, but the usage of the general log as a file is much better. The performance with table logs is horrible, and so you shouldn't use them at all. %, 17%. So the general logs with 5.1 are much more efficient. Now, read and write. When we are writing, the performance in 5.0 decreases a lot. Remember, we had something like 4,000 transactions per minute. Now we have 1,600.
What's the proportion of reads to writes?
It's something like 3 to 10. 3 writes
to 10 reads.
10 reads. In MySQL 5.1, instead, this is much higher than 5.0. So in 5.0, the maximum that we have is 1,600. In 5.1, which is much better, we have 2,200. So you can see that in normal database operations that are a few reads and a few writes, MySQL 5.1 is much much better. If you have only reads, MySQL 5.0 is better. You could say that you can have a master with 5.1 and slaves with 5.0 and you have a perfect world. However, this is not recommendable. So let's...
Replication dies.
Replication can die. Actually, I couldn't find a way to make it crash, but I know that you can have problems. For instance, you can, if you use partitions in 5.1, of course you cannot replicate to 5.0.
There's other strange things that can happen.
Yes, there are other things. But anyway, you don't have to do that, because if you go on with MySQL 5.0, 5.4, you see that the read-only is much better than MySQL 5.0. So this is the first improvement over MySQL 5.1.
The table logs, though, are worse. So
Yes.
what you're saying is, instead of, like when you're showing engine status, that's essentially something that would get written to MySQL data.
As I said before, table logs is really a blunder. You shouldn't use them.
Yeah, sounds like
If you the good thing that is in MySQL 5.1 is that you have logs on demand. So if you want a general log, you just say that. So you don't have to restart the server. In 5.1, you just say general log equal on, and you use it. When you finish, general logs equals off, and you don't have a problem. You don't have to restart the server.
Except that's just for general log. For binary logs, you have to still restart.
General binary logs, yes, you have it too.
Yeah. So general and slow you don't, but binary you do.
Binaries, you cannot.
It's different,
Yeah, I know.
So anything that you would want to get out of it on a regular basis, like you could put InnoDB status to a PID file in case you lost InnoDB and you needed to know what happened last moment before I took the socket away. You can put that to a PID file, but that would be an OS file. Would that be the equivalent of having the same overhead as the table logs? Or would it just read like a file log?
I never tried, so I don't know. But I can inquire.
We've just had some interesting fun with InnoDB in the last couple of days.
Yeah. Who
Have
doesn't?
you used the InnoDB monitor? Because it's like every 15 seconds, I think the InnoDB monitor will spit out, basically show engine InnoDB status into the error log.
It's something. I mean, depending on how often you do it, it can be very demanding on the server.
They say that you should create any of the InnoDB tables that essentially give you that extra status, because it's essentially doing the table logs. So that's why I was curious.
There is a plan to, in the next version, to insert some performance tables in the information schema. Actually, it's not going to be the information schema, it's going to be called the performance schema, where you can find information that you are looking for in a tabular format, instead of looking at the huge InnoDB status. But this is not going to be available right now. Okay, so far the important thing is that you have in 5.4 a huge performance difference between 5.1.33 and 5.4, and this is much better than 5.0 as well. When we are looking at the read and write, also here you have a lot of improvement. Instead of 2200, which was already better than MySQL 5.0, we have 2800. This is the read-only for 5.0, pretty stable. This is the read-only, the rewrite for 5.0. You see the scale is the same as the previous one. Actually, this is the same. Is the same that we use for 5.0 and 5.4. This is the read-only for 5.0. This 5.1, sorry. And we don't reach the same results that we had in 5.0. Read-write with 5.1, we are better than 5.0. Let me show you the same scale. So we go from 1,400 to 2,300. And you see 5.0 is much worse than 5.1. And finally, when we introduce 5.4, this is what we get. A huge difference. The only thing that we have to do is remove your server and put a new one. The same for read-write. The boost in performance is really impressive. This is 60% more than 5.0. Questions before I show the demo? Yes.
How stable is 5.4? The website says that it's a beta and that you should be cautious.
At the moment it's beta, and if we don't add anything else and we keep stabilizing it, it should be GA in July. Now, this is the good news. What is the bad news? The bad news is that somebody wants to add new features to 5.4 and go on until all the new features are in the release. When everything is stabilized, about in December, then we will backport to 5.1 the performance patches. Personally, I don't like this idea because it means changing a GA release, and I think we have convinced the responsible people in engineering not to do it. So if I have my way, we're going to have MySQL 5.4 GA in July, stable and ready to use. In all the tests that we had with the customers, we haven't found any critical bug yet. Compared to 5.1, in the same phase, we had hundreds of critical bugs. So this is very promising. I mean, the patches were made in such a way that we didn't touch, we didn't do any changes that could affect the rest of the server. So it's very, very well contained. Yes.
Are the storage engine APIs identical in 5.4 and 5.1?
Yes. However, they have realized that it's a high priority for everybody that we release 5.4 as a plugin. So there is more attention to the plugin API, and the plugin API is going to be improved, not in 5.4 because, as I said, I would like to go GA without any changes, but in 5.5 it's going to be changed to allow plugins to be more portable. We know, for instance, that plugins for data warehousing cannot be implemented as pure plugins. InfoBright and Kick5, they both have to change something in the core to work, so they are not real plugins. Falcon is not a plugin, Maria is not a plugin, so there are still a few things missing, and these few things are going to be addressed in the next version. But you're not going to see that in this version. More questions?
With 5.4, there's more functionality that's built in for InnoDB. Is there also more information of when things are dumping backtrace and other information so that you can get a feeling for what's causing it?
Only on Solaris at the moment, because the trace is not available on Linux. So, I mean, it's available on Mac, but you don't usually have a Mac as a server.
Yeah. The hard part is that I don't see us putting GDB on a production system. So,
you know, there have been talks of releasing dtrace under a different license. I know that somebody had a talk with Linus Torvalds about migrating dtrace to Linux, and frankly I don't know what was decided and how, or if they can reach a compromise on that. Mostly the only problem that we have for Linux is the license. So once we fix that, Linux can have dtrace and the probes will work as a chart. It would be great, yes, I know. Yes?
Is 5.4 available on both the community and the enterprise versions?
At the moment it's only community.
Okay. Great.
But the plan is that once it goes GA, it will be released for both enterprise and community at the same time.
You or someone tested in VMware in a virtualized environment, because these threads changes and I/O changes and interact with virtualization somehow. So how performance will be affected?
Well, for virtualization, Sun has a lot of technology more than VMware.
No, I know.
But
Many people are using.
I tried it on. I confess I didn't try on VMware because since May 2008 I've been using VirtualBox instead. Not because Sun pays my salary, but because VirtualBox was performing better than VMware on my Mac. So this is why I was using that. But as I said before, I saw the same performance increase with the VirtualBox. Just a moment.
Yeah, two quick questions. One, are there any plans for the performance improvements that were made in 5.4 to go into 6.0?
Yes.
And on Sysbench, is it best to run Sysbench, of course, on a separate machine than the server? and hit the server from a separate machine
Uh,
with a direct network that doesn't
I tried that. Since my data center is 6 servers, I tried using Sysbench on a different machine, and I didn't see any great improvement.
There were
No,
there was no difference.
no.
So you ran it on the same machine
Yes.
as well as running it.
Yes.
In the same system.
So Sysbench itself doesn't add a lot of overhead. You're saying that running the Sysbench doesn't add a lot of overhead.
Let's say that the kind of test that I was using, I was doing in such a way that I was using all the resources of the machine for that test. So Sysbench is not what is going to affect you if you use it in the same server, because most of what Sysbench does is just tell the server to do something. It doesn't do something itself. It's just a client that will receive queries. So if you have the client on a different server, it's not going to do you any good. The only cases where Sysbench was performing better if I was put in a different server was when I used the proxy to test something different. So I had 3 machines, one with the server, one with Sysbench, and one with the proxy. In this case, I saw a difference, but just because the proxy is very CPU intensive. Otherwise, with this kind of tests, you don't get any significant improvement. Probably you can get improvement on a Mac, but not on that server.
Were those figures queries per second?
Queries per
Transactions.
transaction. Yes.
Actually, I have 2 questions. One is the performance gain doesn't depend on the size of the data set.
Size of the data set, not really. No. They depend mostly on the number of connections. So this was where MySQL was having problems in the scalability based on connections, and this is where we get the best improvement. However, the performance was increased in many places. So even with only one connection, you get performance gains. But the data size, I didn't do any test that was trying to test this very thoroughly. I did some tests using partitions, and for partitions I saw that there is a very little improvement compared to 5.1, something like 5% only. But partitions is a peculiar way.
Would you have gotten the same data set in size, like with average row length that you can get from information schema on the tables for the partitions? I would think you would only get a uniform data set if you knew that each partition, say, had the same average row length or number of rows. So that you knew that you were always dealing with a similar size data set.
I really don't have an answer to this because the tests that I ran were either a lot of connections or using a large data set. So using one of these big servers, I was trying to see if there was some difference using partitions with data sets of 300 gigabytes, and as I said, it was really minimum. But I can show you some examples now. Second question.
Yes, another question. Actually, two small questions. Did this change set from Google, or has it introduced any additional custom integration points in the code?
Integration points?
Like some InnoDB specific round trips. Do you know?
I don't know that.
And the second question is probably easier to answer about how does 5.1 compare to 5.4 in a sandbox environment? When we have multiple instances. Have you tried it?
It's the only thing I do.
With multiple.
Yeah, I mean, I have only one physical server, and I have installed 50 sandboxes, and I use a script to stop the first one, start the second one, do the test, then stop the second one, clean the memory, start the third one, and so on. And you cannot do that. Actually, you can do that with physical servers, but you would need 50 servers to do the same thing cleanly. Or you should remove everything from the server and install another one. It's going to take a lot.
So it is at least as suitable for sandboxes as namespace.
I would say that is transparent to sandboxes.
For some of the things that you do, if you don't mind, I might ask you offline for the parameters that you're putting in the MyCNF, because some of them are,
Yes.
They're such a balance that you have to have.
The only parameter that I changed in MyCNF is the InnoDB buffer. Only that.
So everything else is default? Everything else is default?
Apart from the port and the socket.
Okay.
Everything else is out of the box. I can show you the...
And are you following
MyCNF.
that new idea that you don't make it 70 to 80%, that you make it essentially based on your size of your database, your data set?
The database is the same for everything, for every server, because the sysbench will create that in the same set, the same size.
I didn't get you, I'm sorry.
When you run the sysbench, when you prepare, it has two phases. The phase that you prepare, it will create the data. And in the phase when you run the queries on the data that was prepared in the previous phase.
Okay. So essentially you have to assume that your data set will be a certain size and then size your InnoDB buffer before you run that test?
Yes.
And so you are assuming a certain data size versus 70 to 80% of your memory. For the InnoDB
Does the
buffer.
InnoDB buffer hold all of the data in memory?
Oh yes, definitely.
Okay.
It does. There is no problem with that.
And are you sizing your InnoDB buffer to be 70 to 80% of whatever memory is allocated to that system? Or are you sizing your InnoDB buffer based on the data set that you expect?
I see. I actually was pessimistic, so I gave double the size that I should have given in that case. So the data was something like 3 gigabytes, and I gave 5 gigabytes of buffer.
Okay. Thank you.
So welcome to my data center. Let's see if we can increase the font. So here we have from MySQL 5.045 up to MySQL 5.4.1. Actually, this 5.4.1 doesn't exist yet. I just used it because I compiled from source yesterday. What I was using at the moment when I was running my test was MySQL 5.3.33 because I had the code, but I didn't know which version was eventually going to be published. So my tests were run with MySQL 5.3.33. But I can tell you it's 5.4 because the code is the same. Let's start with something slow first. Okay, this is the MyCNF. As you can see, the only things that we have here are just are not going to influence the performance, and the parameter that is changing is the InnoDB buffer, that is 5 gigabytes. Everything that we have in this in every sandbox has the same configuration, except the ports. Sysbench read-only. So we clear the server and then we start, and this is the preparation, and finally we have the execution. Okay, this runs for about 1 minute. In the meantime, let's do the same thing in the Mac. Yes. I don't have 5 gigabytes of RAM here, so I will give only 1 gigabyte. Now this one has finished, and this is the result. 3,800 transaction per second. Now we run the file 4. In the meantime, we can see the results here. As you can see, my Mac has not the same performance as the other one.
But you made the CPU fan come on. Got it working.
It's suffering a little bit. So this one was read-only.
The good news is that Giuseppe's laptop simulates what somebody would have if they had not only their MySQL running on like, say a 32-bit system, but also, they're running their mail and their web server all on the same machine, so it's pretty much the same.
It's pretty much the same, yes.
So, forgive me, that looked like it was read-write on the Mac?
Yes, it was read-write. Now, let's do again with read-only. Here. So we have 4200 against 3800. We can run the read-write. I'm not cleaning the buffer now because it takes something like 5 minutes to, or maybe less, but anyway, to clear the buffer here, you have to create a table of 32 gigabytes and then remove it. As you can see here, my activity monitor, it's really using it.
I guess it's not percent CPU, is it? With 140, it can't be percent CPU.
I have 2 CPUs here, so it means that it's using
You're saying
whatever.
140% of one CPU.
It's using whatever is free from Firefox and Thunderbird and everything. Yes.
I might have missed what changes in the server itself have caused it to be faster?
Well, yeah, that's all it's like. This is a 5.4 versus 5.1. Lots of stuff. Look at your slides.
Okay. Got lost in Boston.
So 284 read-only against 219 read-write. Let's do with 5.4 now. What we have here, this is read-write for 5.4. And now we have to run read-write for 5.1.
You're too fast of a typer. You typed so fast we didn't get through the example by the time you're done typing.
Which example? I didn't type anything. I was just...
Well, no, I know, but the starting the one and stopping.
Come on, this is another presentation. I did that in November. You were not here, so you're excused.
I presented on Sandbox myself, I think. So. It's a good tool. I used it in writing the book.
Okay. So read-only for MySQL 5.4 is 465 compared to the previous one, which was 284. So even for my small Mac, this is something. But let's do read-write. Here we have 2,200. This was MySQL 5.1 compared to 2,800 MySQL 5.4. Mostly we have one result to wait for. As you can see, the only difference here is using a different server. No tuning, no consultant's fee to pay. It's everything in one go.
Thank you very much.
Question.
Yes.
Were any of the optimizations independent of NODB, and if so, did you run it with another storage engine such as Vulkan?
99% of the improvements were for InnoDB. There were some minimal improvements that affected everything that was really minimal. As I said, for instance, I found that there was 5% improvement in partitions that I call a side effect of the general improvements. But most of the things were done for InnoDB. So now we have 341 transactions per second compared to 219 transactions per second in MySQL 5.1. It's a big improvement also on a small machine like this. So what else we have to say about that? The slides will be in my blog tonight or tomorrow morning, depending on which time zone I'm going to wake up today.